Hello everyone, my name is Almadiyah Surya Saputri and together with Team Visioner, we are honored to present our project Visioner Bridging Artificial Intelligence and Human Collaboration for Inclusive Accessibility Solution. Now imagine trying to cross a busy street but the only information you have is there is something white nervy. Not a car, not a person, not wall, just a color. Now imagine having to really want that kind of information every single day. For more than 2.2 billion people around the world living with visual impairment, that's often what today's effective application sound like. That's exactly the challenge we want to solve. So, why does Visionary matter? According to the World Health Organization, more than 2.2 billion people worldwide live with some form of vision impairment, ranging from moderate vision loss to complete blindness. And also accessibility technology has advanced significantly over the years. Everyday tasks like crossing a street, finding a petty seat, or reading signs are still surprisingly difficult to do independently. Today, there are already several great effective applications such as Microsoft Sync AI, Google Lookout, and Be My Eyes. And to be fair, each of them does its job really well. But here's the problem. Each application focuses on only one specific task. One reads text, another records object, another connects user with human volunteer, and in reality, whoever people don't experience challenge one at a time. Everything happens at once. As a result, users often have to switch between 3 or even 4 different applications just to complete something as simple as walking to a nearby store. And honestly, switching between applications might sound like a small inconvenience until you are standing at a busy intersection and need immediate assistance. That's when every second truly matters. So, before building any solution, we want to understand the real problem first. Before reading a single line of code, we spend time talking with people who experience this challenge every day. Member of the Sahabat Mata community in Semarang, along with university students with visual impairment. Instead of starting with technology, we started by listening. We didn't begin with a long list future or assumption. Instead, we simply asked them to share their everyday experience. After studying too many different stories, TK challenges keep coming out. First, object detection almost always requires user to press a button every single time they want information. And second, the description provided by exciting AI we are often too limited. For example, hearing there is something white nervy doesn't tell you whether it's a wall, a door, a parkour, or even the edge of a staircase. And finally, and this was something we didn't expect, participants began asking AI to replace human assistant. Instead, they want AI and human to work together. They want the freedom to instantly talk to a real volunteer whenever a situation becomes confusing or uncertain without leaving the application we are already using. That insight become the foundation of Visionera. So, how did we turn that insight into a real solution? Let's take a closer look at how Visionera works.
That feedback became the blueprint for Visionara, a single web-based platform that brings together 5 things that used to live in 5 separate apps: AI-powered scene description, automatic object detection, GPS navigation, voice interaction, and a live volunteer call system. The idea isn't just to add more feature, it's to remove the friction of switching between apps so users can stay focused on what's actually happening around them. We follow the waterfall software development model since our requirements were clearly defined upfront through the interviews. That means moving through 5 stages in sequence: reviewing existing literature, analyzing user requirements, designing and building the system, implementing it, and finally testing it with the same community that helped shape it in the first place. On the technical side, we built the backend with Laravel, connected to a centralized database, and used Google Gemini Vision AI as the engine behind our scene description. Here's the big picture. A user opens Visionara in any modern browser, no app install needed. From there, 5 modules all talk to the same central database: AI vision, GPS navigation, voice interaction, the volunteer call system, and user management. Because everything lives in one system, a user can move from "let AI describe this room" to "actually let me just talk to a volunteer" without ever leaving the platform.
Volunteers get a mirrored experience. They toggle their availability on or off and get an automatic notification the moment someone needs help. No need to keep the app open and staring at the screen. Now here's the core of it. AI vision. Once activated, the camera continuously captures and sends image to Gemini Vision AI. No repeat button pressing required. Instead of just naming isolated objects, and when AI isn't enough, say in an unfamiliar building or unimpacted obstacle, the volunteer call system kicks in. One tap connects to support seeker to unavailable volunteer over live voice.
We think just one feature that technically exists. We want them to be reliable. So we run structured functional testing across every core feature. Automatic object detection, voice interaction, the folder call system, user authentication, and profile management. All it a 100% success rate. AI vision came in at 95% with the one failure trace to allow light image the model can parse clearly. GPS navigation landed at 93.3%, mostly due to one temporary signal drop during outdoor testing. We also measure speed because in real-world use like matters. Voice output respond in under a second, 0.9 seconds on average. GPS route generation took about 1.4 seconds. AI vision processing average 2.1 seconds, and setting up a volunteer call took around 2.8 seconds, depending on network condition and volunteer availability. Numbers only tell half the story, so we went back to our original participants and let them use the finished prototype. Their feedback was honest and specific. One participant said the environmental description were much more detailed than other applications they'd used before. Another appreciated no longer needing to repeatedly press a button to scan. A third put in simply, when AI cannot explain the situation, I can immediately ask a volunteer. And one comment stuck with us in particular. Everything is available on application, so I don't need to switch between different apps. That's the exact problem we set out to solve. Beyond the technical achievement, this project connects to something bigger. By improving access to environmental information and independent mobility, Visionara support SDG 3, good health and well-being, SDG 4, quality education, SDG 9, industry, innovation, and infrastructure, and SDG 10, reduce inequalities. Accessibility is a side feature here. It's the whole point. We are not calling this finished. Our evaluation involved a relatively small group of participants, so we know the results should be over generation yet. Going forward, we want to speed up AI response time, expand the range of reasonable objects, improve GPS accuracy in crowded areas, and explore offline capabilities so the platform depends less on sustained internet access. We are also planning from usability testing using instruments like SUS and UEK. Visionara start with a simple observation. AI is powerful, but it is everything, and sometimes what people need most is just the option to reach another person. By bridging AI and human volunteer into one place, we hope Visionara make independence a little more reachable, one interaction at a time.